Hi, this is me 180949 presenting you the simulation and code for the ZUMO robot. First, let's go to the code. Here we are including some header files that are used in this code, and these are some header files explained in down there. Here we are defining the sensor threshold 300 and the above line. Sensor threshold is 300 and above line we have this for the bot that when the bot is above the line, this define is then working. Now we are defining the turn speed, that how much speed the bot will use when it is turning, and this is the speed when the bot is moving in a straight line. Now we are defining the line thickness, that is 0.75. Now this is inches to Z units, that is the conversion of inches into the units that is needed by the ZUMO board in the simulation. This is overshoot, that when the line thickness and the converted is not on when the board is not on the line, this will initialized. Now we have push button 12, so you can see that the push button is connected to the 12th pin. Now character path 100 means we are creating an array of 100 characters that the path is where the path is stored, and file my file means where the path is to be stored. So basically our project is to run a ZUMO bot that is in the Proteus files already. What we have to do is that we have to connect an SD card that stores all the information of the bot, that where the bot is turning and what path it is taking. Here we have the chip select 10, that you can see here, that 10 pin is for the chip select of the SD card. Now while serial port, here we are initializing the SD card. So when the SD card is initialized, it will print initializing done. If it is not initialized, then initializing failed is displayed on the screen. Now serial begin 9600 is the baud rate for the UNO. Now unsigned character 6 means we in int sensor means we have 6 sensors. Short count 0 and last count status 1, that when there is nothing it will get to 0. Uh, Turn directions, we have one direction at a time where the bot will turn. Now you can see that there is a ZUMO reflecting sensor, that means it is the sensor we used for the turning. The sensor will sense the path and get the message to the board, where and then the microcontroller performs what to do. Here we will be finding the motor speed and the motor direction. Now this part is a count 0 and last at a 0. That means each time it takes a turn, the it it gets to the new path. It then takes the new path and go on and then store that information. Here is for the left turn L. So when there is a left turn, the first the motor speed will be 0 and then turn will be taken. Now that turn dir function is here. I can the turn dir, it is down here. Turn dir, that unsigned turn character dir. The turn that the bot is taking is stored in the dir character. Then this dir character is stored above here. It is here, the dir. So when the bot is taking a turn, the information is stored in the character dir, and this dir function is called here, that is mentioned here. So dir is that we have four possibilities: left, right, straight, and back. Back means turns the bot will take a turn of 180 degree. Now count plus is that the bot is adding all the information. Now this is the main thing where what we have done is that we need to save the path in the SD card file. Here is the file. Uh, if it is turned left, then it will show L. And when it is going straight, the it is printed S on the screen, R for right and B for back. Now we have the offset and the power difference here. Here we are computing the two motor powers M1 and M2, that what is the difference when it should take a turn, because when we want to take a turn we need to adjust the motor speed as required. This is the line section where we can see that sensor 0 and above line sensor 1 sensor up to all the 6 sensors. It shows that the line is on the sensor. If a sensor is if the sensor input is changed, the microcontroller will decide what to do. Unsigned character found left, straight, right, and back is set to 0 initially. This is for the left and right turn. Above line sensor 0, that means if sensor 0 is found to be 1, the left board will turn left, and when the sensor 5 is on, when the sensor 5 is high, the bot will turn to the right. That is the dir function that I have told earlier. And this is the switch case when the when right turn is called, the turn angle of the bot will be 90 degrees, like plus 90 degrees from towards the right. And when L is called, it means plus 270, that is to the left. And when back is called, 180 degrees is called, that means it will move in the reverse direction. So here is all about the code. Now I can I will explain the working. Here we are having the virtual terminal that it says the SD card is initialized. Here we have the path. So we can see that the bot is now in the initial position, and this is the switch button. When we turn this on, the bot will start to move and the path will be saved here. Now this is the notepad file where the path is to be saved. This is the initial path that I have saved earlier. Now when I press this button, the bot will start to move. So you can see that it takes a left turn, path saved L, again left turn, the L is saved. Now again the left turn, now it's turned back so that path B is saved. We can say that when S is saved, when there are two options left or straight, the bot will have to take the first it will take the turn, and when it is nothing found in front of it, then it will be the straight path like this. Here the bot will go straight. The simulation is over. Now uh, when we reload it, it will show the path like left and forward, all this. This this is the initial one, the last we have saved. From this, the bot will go left, 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 back, straight, and all the path is stored in the SD card file here. This is all about my simulation code. Thank you very much.